Let's take a look at a pretty common code example. We have a person class that has a name and age. Then we have a print person function that takes in a person and prints out their name and age. And then finally we have a main function that creates a person and then prints out the person's details. And it works fine. But what happens now if we pass a null? We knew the function accepted a person type, but we never specified that it could or could not handle null. But let's give it a go. We can see we get the dreaded null pointer exception. So why is this happening? I know that Java has a non-nullable annotation, but the code runs just fine without using any notations, and this problem applies to more than just Java. Many languages like Java, C++, Python accept null as an equivalent type to any other type. But why is that? A person object has fields. The null type doesn't have fields. Why is it that programming languages are happy to accept the two things as the same type when they're clearly different in structure? Let's take a look at an example with null safeties in Kotlin. Here's that exact same code, but in Kotlin. You can see it works just fine. But what happens if we try and pass in null to the function now? You can see it throws a build time error because we've passed in a null value to a function that doesn't accept a null type. Why is this? It's because in Kotlin, every type has two different versions of it. One is the original type, which can't ever be null, and the other is the nullable type, which we see in lots of other languages, where the type can either be the type itself or null. Alright, let's handle this case and add a question mark to the person type. What this does is transforms the type that the function accepts from a person to a nullable person. But you can see it's created some more errors with these red squigglies, which are saying, wait a minute, you can't print the person's name and age because they might not exist. Let's look at how we can handle this. Here I've used the question mark operator, which says if this value is not null, then we've used the let keyword to store the non-null person in a separate value. Then we can access this not null value, and we know in this scope this value will be not null. Otherwise, we've used the else operator, which is the question mark colon, and it says if this value is null, then do something else. And here we print out the null person received. Now you can see that both the print person function and the main function don't have any errors associated with them, and it prints the expected result. Thanks for watching.